This is another non-homogeneous equation where our g of x is said to be quadratic. As you can see, the right-hand side here is quadratic in form. Now, we are going to use a specific method here since we have identified that this equation is non-homogeneous. The general solution for non-homogeneous equation is expressed in this manner. Why? Take out its y because that's the value of your dependent variable here, is equal to y sub c plus y sub b. Y sub c is a complementary solution of this equation once we assume that the right hand side is 0. Hence, we are assuming a homogeneous portion of the left hand side. That's just for y sub c. So we are going to use the same process we did before and the understanding of 4 possible general solutions. That is, if number 1, the roots for the auxiliary equation are distinct and real, if they are also repeated and real, if we have imaginary and repeated imaginary roots. We will have it later. Now for y sub p, this is what we call as the particular solution of the equation by solving the coefficients presented in this table. This table here shows the correct forms of y sub p per g of x. Since our g of x is quadratic in form, then we are going to use the third row giving us this form, ax squared plus bx plus c. We are going to solve later on the a, b, and c coefficients that will allow us to come up with the correct y sub p, which will be paired to whatever y sub c will be solving later. So let's start first with y sub c. Of course, we are treating the same process for homogeneous equations. So the first step is to come up with our equivalent equation with differential operator d. So we will have here f of dy is equal to 0. Hence, our equation now will have here d squared minus 3d plus 4 times y is equal to 0. Then our auxiliary equation, f of m is equal to 0. Hence, we will have this form, m squared minus 3m plus 4 is equal to 0. We just need to solve for the roots of this given auxiliary equation to come up with the correct general solution for our y sub c. So let's start by looking into the possibility as to this equation can be factored or not. When we look at the possibility for factorable terms or trinomial, now there are some possibilities where we cannot factor something like this. So we are introducing or reintroducing our quadratic formula. So our m is equal to minus b plus minus a, it's a small letter b, square root of b squared minus 4ac over 2a. You can also use this if you have problems in factoring quadratic trinomial, because our auxiliary equation here is a quadratic trinomial. So our a is 1, b is negative 3, and c is 4. So substitute that here, minus negative 3 plus minus the square of negative 3 minus 4 times 1 times 4 all over 2 times 1. So let's continue. This is now positive 3 plus minus the square root of 9 minus 16. And as you can see, this is negative. That's an indication that our trinomial earlier is not factorable. And at the same time, we will have here imaginary roots. So please take note of that over 2. We'll have here 3 plus minus the square root of negative 7 over 2. So we can rewrite it in this manner. 3 plus minus, we take out or we factor square root of 7 and square root of negative 1 all over 2. So our roots here are expressed in this manner. 3 plus minus square root of 7i all over 2. These are the roots, and since obviously our roots are imaginary, so we are going to use the general solution for auxiliary equation having imaginary roots. But since the general solution follows this form, okay, this is the general solution, we will have it y sub c e to the power of ax times c sub 1 cosine of bx plus sine c sub 2 rather plus c sub 2 sine of bx, we need to establish the correct A and B. It's not the A, B, C here because we use this for quadratic formula. It would be in this form, M is equal to A plus minus BI. And since it's still a rational expression, we can separate our numerators into this form, 3 halves plus minus square root of 7 halves I. Hence, our A, the A for our general solution is 3 halves, and our B is square root of 7 halves. So our Y sub C, taking into consideration all of this, e to the power of your A, which is your 3 halves x, times C sub 1, cosine of your B, square root of 7 halves x, plus C sub 2, sine of square root of 7 halves x. This is just our Y sub C, because we need to come up with our Y sub B for the general solution of this non-homogeneous equation. So with that, let's proceed to our Y sub P. Our Y sub P, as indicated by our table earlier, is in this form. So we have Y sub P is ax squared plus bx plus c. Okay? Now, to continue this, let me rewrite the given here. Okay, let me rewrite the given. Minus 3, the first order derivative, plus 4y is equal to negative 16x squared plus 24x minus 8. Okay, so since our highest degree here is 2, we need to come up with the second order derivative of this y sub p as well. The first order derivative is 2a x plus b. And since c is a constant, its first order derivative is 0. For our second order derivative, you will have here 2a, and again, the first order derivative b is just 0. We'll be using this because in solving for y sub p, we'll be substituting the versions of y sub p in this given equation. For y sub p is equal to minus 16x squared plus 24x minus 8. Okay, so by substitution, you will have here, okay, I'm gonna use this space here, and of course I might be using additional spaces later, so please bear with me. You have 2a, okay, minus 3 times this 2ax plus b plus 4 times this, you will have ax squared plus bx plus c, and this is okay, let me move this here. Let me move this, because this is equal to minus 16x squared plus 24x minus 8. Okay, let me simplify the left hand side. So you will have here 2a minus, that's 6ax minus 3b plus 4ax squared plus 4bx plus 4c is equal to minus 16x squared plus 24x minus 8. I'm rearranging the terms on the left hand side so that it will be corresponding with the right hand side. You'll have 4ax squared, then the terms with x minus 6ax plus 4bx, then you have plus 2a minus 3b plus 4c is equal to minus 16x squared plus 24x minus 8. We are doing this so that we can pair the terms with the same coefficients. To retain equality, they must be also equal to one another. And with this, we can solve for a. The second pair is this, minus 6ax plus 4bx is equal to 24x, this one here. Since we will be solving a here, we will substitute that here to solve for b, and once our a and b are done, we can now solve for c. Let's start with a first. So this is by dividing 4x squared, our a is negative 4. This is our a. Okay. For our substituting that here, so you have negative 4 times negative 6, so that's 24 um, yeah, negative 4 times negative 6, 24x plus 4bx is equal to 24x. We have the same term here, so 4bx is 0. Dividing 4x both sides, b is conveniently 0. The last pair now is 2a minus 3b plus 4c is equal to negative 8, as this is the constant here. So by substituting a and b, you have 2 times negative 4 minus 3 times 0 plus 4c is equal to negative 8. This is negative 8, that's 0, plus 4c is equal to negative 8. Of course, 4c is 0, c is also 0 here. We now have a, b, and c. And take note that our y sub p is expressed in this manner. Hence, we will have the final form for our y sub p. Our y sub p is a, x squared plus bx plus c. So our y sub p being a is negative 4, x squared. Our b is 0x and this is 0. So our y sub p is simply negative 4x squared. Surprisingly, it's just one term. So y sub p is now done. Y sub c is this here, though very long. That actually comprises our solution because the solution is the sum of both. Let me use the remaining space here as our y is equal to y sub c. So that's c plus y sub p. So y is equal to our y sub c earlier, e to the power of 3 halves x times c sub 1 cosine of square root of 7 halves x plus c sub 2 sine of square root of 7 halves x plus your y sub p, which is, since it's minus, so I'll just simply change it. We'll have minus 4x squared. This is now the final solution of our given original equation. So please bear in mind the proper y sub p based on our table and the processes we did for this video. Thank you very much for watching.